By now you have finished watching the Unit 1A videos, and we're on to Unit 1B, the scientific method, measurements, and the metric system. Here are the learning outcomes for Unit 1B. Notice that they start with the number 5, and that's because these are really the second half of the Unit 1 learning outcomes. The first 4 were for Unit 1A. This is actually the second video in Unit 1B. The first video was called What is Science? And hopefully you've already watched that. That video was not produced by me, but by a colleague of mine at the City College of San Francisco. Did you come up with an answer to what is science? This is a pretty interesting question, because if you asked a lot of people, I think you'd come up with a lot of different answers. I like to think of the answers as falling along a spectrum or a rainbow, like this one. At one end of the spectrum would be answers such as this. Science is a bunch of facts that need to be memorized. At the other end of the spectrum, you'd find answers like this. It's a way to learn how things work. Now, you can probably guess where I feel science belongs, and it's over here. Science is a process. It's a way of explaining how things work. Now, people who think that science is just a bunch of facts to be memorized probably think that science is pretty boring, and so would I. Yuck, just memorize a bunch of things? Do you think these kinds of things when you think of science? Science is hard. Science is only for people who are good at math, or I'm not good at science. If so, then maybe you're stuck on the wrong end of the rainbow. These are more of the kinds of things that I think when I think of science. Creativity is important in science. It's important to be able to think out of the box and imagine new things. Diversity is also important in science. We don't want all scientists to be the same. We want people to come in with new ideas and fresh perspectives on solving problems. Science will never have all of the answers. It's just not possible. Scientific thought also changes over time. And sometimes science is wrong. Sometimes scientists make mistakes. In the video, What is Science?, the narrator said at the beginning that we all use scientific inquiry all the time, and that's true. For example, we start by making an observation. Let's say you walked into the house and you smelled onions cooking. And then you ask yourself a question, I wonder what's cooking, I wonder what's for dinner. And then you might investigate and gather some data. Let's say you peek in the kitchen and you see some meat on the counter, and then you see some tomatoes, and then you realize it's Tuesday, and so maybe you think to yourself, it's Taco Tuesday, we're probably having tacos tonight. And so you make a guess, a hypothesis. That's the scientific method, and you did it in a matter of a few seconds without even realizing it. So we all do this all the time. Now, you might have to modify your hypothesis if you come across new information. Maybe you walked into the kitchen and you saw a couple boxes of spaghetti on the counter and you realized, oh, we're not having tacos, we're having spaghetti, and Mom's making spaghetti sauce. In that little description I just gave you, I mentioned two different things. Observations and hypotheses, and I want to make sure that you know the difference. So an observation is a fact, something that you could measure maybe. For example, my iPhone has a cracked screen. That would be a fact. The boy is crying. Our puppy runs faster than our older dog. All of these are observations, and some of them are measurable. A hypothesis, on the other hand, is an educated guess or a tentative explanation about why something is happening. For example, I think my sister dropped my iPhone. Or, the boy is crying because he lost his toy. Or, our puppy runs faster than our older dog because he's younger and more agile. So now it's your turn. I want you to pause the video, take a look at these statements, and decide if they are hypotheses or observations. Here we go. The geologist suggested that a large crater was formed by a meteor impact. That is a hypothesis. Now, if the sentence only mentioned that there was a crater, that would be an observation. But because the geologist suggested an origin for the crater, which was a meteor impact, that's a hypothesis that needs to be tested. My sister acts weird because there is a full moon. That's a strange statement, but in any case, because there's that causality, because there's a full moon, that is a hypothesis. There is a Category 3 hurricane moving towards Florida. That's an observation. Hurricanes are assigned category numbers based on their wind speed, and that can be measured, and its movement towards Florida can also be measured with instruments. The deepest point in the ocean, the Mariana Trench, is 6.8 miles below sea level. That is an observation that can be measured. My sister acts weird when there is a full moon. Now this is different than the previous statement because there's not the because, there's just a when. So that's actually an observation. And then finally, since plants like sunlight, global warming will make plants grow larger. That is a hypothesis that can be tested. This is the screen we had earlier, and I just want to emphasize that this set of steps is often known as the scientific method. Make some observations, ask some questions, gather some data, make a hypothesis, revise your hypothesis. Here's an earth science example of using the scientific method. This is Dr. David Gillette, and he's a paleontologist, which is somebody who studies fossils. In 1985, in New Mexico, he came across 8 dinosaur bones that were unlike anything he had ever seen before. He made a hypothesis that he had come across a dinosaur that had never been studied by scientists before. And he based his hypothesis on prior knowledge because he had previously studied lots of dinosaur bones and the observations that he made when he saw those new bones. He then made some predictions about how these bones would be different from other dinosaur bones, and then he did some research. He gathered a lot of data, and he measured a lot of other dinosaur bones compared to these bones. He did a lot of research on other people's studies of large dinosaurs. He analyzed the results, and then he drew some conclusions and communicated the results to the scientific community. Indeed, he seemed to have found a brand new species of dinosaur, which he called Seismosaurus, and seismo is a word that means shaking, as we will learn when we talk about earthquakes and seismology. It eventually got a more scientific name. He did this entire process in a very similar manner as what we would call the scientific method. Today he's waiting for more evidence, hoping they find new examples of this species that he can compare to the ones he found. So science is a method of understanding nature, and it involves a number of different kinds of things. First of all, critical thinking and reasoning, which is the ability to think clearly, be open-minded, and be good at communication and problem-solving skills. You also have to make unbiased observations. That was touched upon a little bit in the What is Science video that you saw before this one. In that video, the narrator called it evaluations, and she talked about the difference between observations and evaluations. So when you make your observations, you don't want to accidentally put in your opinion or your evaluation. For example, you see that a boy is crying, and that's an observation. But if you say that the boy is crying because he's sad or hurt or scared, then you're putting in an evaluation. And until you have facts collected, you don't want to make an evaluation or a biased observation until you have all of the information. Certainly, science involves asking questions. How do we know that? How can we support that with evidence? Communicating information is a very important part of science, so that everybody can be involved and test what has been found. And then the scientific method that I just described, that asking questions and developing hypotheses, can happen in a couple different ways. You can make an experiment, for example, testing out which instrument is best to detect air pressure changes. Or sometimes you can't do an experiment. For example, you can't really do an experiment on a tornado, so you might have to just use observations and make a model, maybe a computer model, to understand how tornadoes form or how tornadoes move. Sometimes, You're just surprised by things that happen, like a meteor that falls out of the sky, and then your curiosity is piqued. Finally, I want to make sure that you're clear on the difference between observations, hypotheses, and scientific theories. Now, theory is often misused in everyday speech, such as, I have a theory about who stole my donut, or I have several theories about how we can solve this problem. That's not the right use of the word. In those cases, really the word hypothesis would be better. In science, a theory is an idea supported by a lot of evidence, and it's passed many tests by many different testers. And what that means is that it isn't just one group of scientists who found something to be true, but scientists all over the world can repeat whatever's been done, experiment, model, and they find the same result. It supports new observations, and it can be used to make successful predictions. Scientists have much greater confidence in a theory than in a hypothesis. I don't know if Einstein really said this, but can't really change facts. Here are two scientific theories that we will be studying.